From TE Connectivity, this is Maker to Maker, conversations between engineers about engineering and the beautifully messy process that is design. I'm your host, Brooke Glassman, and today I'm talking with Senior Director of Engineering at TE Connectivity, Ting Gao. Welcome, Ting.
Thank you for having me today.
You have a background in physics and chemistry. How has that background, helped to make you a better engineer and has helped allow you to solve these really complex problems that you and your team are working on?
When I was, doing my master degree, and my major is in the semiconductor physics, and that time is, when people are so excited about the nanomaterials, and there's one major area is looking at the nano silicon materials. So, for decades, silicon is known as the indirect bandgap materials. So what that means is they cannot be a laser, they cannot luminescent, or etc. And however, in the 90s, and people find that by making the silicon size as small as possible to the nano size, and the band gap shift. So in that case, the silicon can emit the light or be luminescent. So this has opened a new door and to say, oh, we can get in the laser on the silicon chip. That's great. That will, increase the data transition speed, and we can do another things on the semiconductor substrates, or etc. And then, that's one area I was really interested. So I'm starting in the optical electrical side to targeting the application in that area. And however, we find, yes, the nanosilicon can emit light. They can be luminescent. And however, they're not stable. So whenever they're exposed to chemical vapor or even water vapor, and then the luminescence will quench. And to us, it's totally a failure of our project, is to say, oh, we couldn't get a device stable. And, nowadays we are in the industry, we all know is the stable performance is required for the product. So that time we said, okay, gosh, so this project cannot move forward to anywhere. And however, later we find a literature or article published on Science, which is the top journals in the science area. And then a group in UCSD, University of California, San Diego, a professor, they using the similar phenomena. And however, they use this same performance of the materials, the light quench with the exposure to the chemical vapor as chemical sensor. And this has really opened a door for me and to say, wow, so some things you see that's not a good conclusion on one science project from working from the physics side, and from the chemistry side they're totally looking at it different ways. So this tricked me and to reach that professor and to say, I'm really interested in this work, and I want you to know is the cutting edge of the science and how they can change the world, or how they can apply for the different applications. So so this is the way is I applied for the graduate school in that team and got in. Very, very lucky. And so I pursued my chemistry degree in UCSD. And and then explored multiple different ways to looking at how to use in the nanomaterials and later polymeric materials for various sensor application. So I want to use this as a story is to say is we had to think out of the box. So another time is when we settle in to say this is the target we want to go, and we already kind of narrow down our mind and to say, oh, this is all what we can do. But on the other hand, if we touch those kind of things in different areas or different aspects, and you will find, there's much, much more things you can do. There's much more, directions, various directions you can go. So this is the thing is I always excited about is about the science and technology, because they have tons of the possibilities.
I like that perspective that sometimes while maybe in one realm, like in the physics realm, there stuff looked maybe like a failure or that it was kind of a dead end. But when you shift your perspective and maybe widen the lens of what you're looking at, it led to so many more opportunities, and it actually completely changed your path a little bit. Now you were pursuing chemistry. So it is important to keep your mind open, I guess, to possibilities, and that sometimes the solution you're looking for isn't exactly expected.
Absolutely. I think open mind is very important, in a way, if we're looking at the technology solution and or scientific ways and, always being open-minded.
Yeah, absolutely. And you were talking a little bit previously about how important it is to frame the question and to frame your goal of what you're looking for or what you're doing. Can you talk a little bit about why that's so important to you and how that does help you keep an open mind on your projects?
I think it's very interesting. It's a lot of time during our daily work, right? And some of the engineers, they will approach us to say, hey, because your team has the materials expert, can we get the materials with such kind of properties? And then and a lot of time we will find is no, that's not the right question. We need to phrase the question to identify what's the real problem. And if you can carve out what is exactly the problem we want to solve, and then similar as previous, right? If we have the open mind, and then there's ways to solve those kind of problem. And I always say is sometimes the most challenging part is to identify the right problem. If you identify the right problem, and then most time you can deliver the technology towards that needs. I can give you one example. Is for one collaboration we did. In fact, it's for automotive application, and then they're looking for one materials which can sustain higher temperature. And the first question they're asking us is there any polymer materials that can sustain temperature above 500 degrees C and then even above 1300 degrees C or 1200 degrees C for shorter time. And then when we got that kind of question, and we basically said, this is a mission impossible because we don't know any of the materials they can sustain the temperature as high as they described. And on the other hand is, after discuss with them more details and you say, hey, what's the application you using these materials for? And on the other hand is, what's the real requirement about this material to be functional, for your application? And then we realize is, the thing is they want polymer materials is because they like the flexibility of the material. And then on the other hand, they want a high temperature performance is because they want to making the materials is, to become a spacer to protect the device, not shorting the contact. So they need to maintain the electrical insulation and also the mechanical, stability, at that temperature. And they don't need this one to be sustained like a 1200 degrees C forever. And also is usually after you expose 1200 degrees C, basically, they don't need to use that again, right? So after identify those kind of things, and then we have several brainstorming to discuss about to say, oh, okay, now we understand the application. So basically is what they want to looking at the materials properties has two different temperature range and with two different properties. So, flexibility at the beginning, at the end, they don't care about whether that's flexible or not, but they only care about is the dimension and also the electrical insulation properties. So in this way, we develop the materials, which is a softer polymer-based materials. And then, however, we put some kind of fillers inside. So, when they stay temperature under 500 degrees C and they stay as polymer. And then, you can bend them, you can, you can have any kind of polymeric, performance as needed. And on the other hand is when they exposed to temperature above 500 degrees C, they turn into ceramic materials. So in that case, they became, they can sustain higher temperature, 500 degrees, 1200 degrees, no problem. And, they even burn those kind of materials with a torch and then they're still fine.
So I guess maybe the message there too, like you were talking about, was really defining your requirements and your priorities, because sometimes you're asking for a lot and it becomes a really big ask and no material is perfect and can do maybe everything. But I feel like trying to sustain really high temperatures, being suitable for electrical applications is becoming very relevant, as you said, in the automotive space, in the electric vehicle space. So I imagine that's a topic you guys are touching a lot. You touched on a little bit about 3D printing, which I know is also an evolving space. So not only with a lot of different types of materials too. I know there's metal 3D printing. The applications across the industries are pretty widespread, whether you're looking at maybe, automotive and our industries, or even medical to rocket engines. There seems to be a huge area of potential. Where do we stand right now in terms of our 3D printing capabilities, and what are you excited to see in the future?
3D printing, if we're looking at the technology, it has been existing for decades. If we think about the regulation or sustainability side, and we need to add in quite user-friendly, shouldn't say user-friendly, environmental friendly, fillers or flame retardant packaging inside. And then those kind of things, whether they will impact or affect the printed part, it will, right? So the materials, they still have ways that we need to improve to what we have today. And on the processing wise, is the resolution and tolerance of the 3D printing is keep improving, no doubt. I think, if we compare the parts printed 5 years ago and nowadays, amazing day and night. And however, if you compare to the molding processing or other processing, and then the surface finishing and tolerance, as a comparable, they meet the manufacturing standard. I would say there might still be a little bit of gap there.
Room for improvement, maybe.
Yeah. Mm-hmm.
Yeah, the repeatability part and the consistency part, I feel like in 3D printing is can be a little bit of a challenge. Like you said, maybe depending on the material, depending on the printer, there's a lot of variables. It feels like sometimes. I guess this kind of brings us into the topic of innovation. There's a lot of innovation happening with materials and 3D printing, and also I know within your group. Can you talk a little bit about your perspective on the difference between invention and innovation and some of the key factors there?
People always like invention and innovation, right? So and sometimes people using this word, I would say think they're similar, and however they're not. Invention is you develop something new, and I would say it's quite a challenge. And on the other hand, innovation is I think innovation is even harder than invention, because innovation is usually you do want the work. So when we're talking about the innovation, it's a very, very exciting area. It has to see some economic benefit out of that. And however, invention, anything new, you can talk about invention. And this is back to, that really matters about when we do the decision about whether we file patents or not as well. Because it's usually when we develop something new, we also looking at is whether those kind of invention adding value to our product or not. So if we do see the opportunities that those kind of invention, they can making our product faster, smarter, or with additional function or higher performance, and then we will use in our end product. And those kind of things we are eager to file patent, and then because we believe that will be in the real application area. And the some of the invention, even we are excited, and then if we don't see the economic benefit behind, and then we might just to say, hey, this might not be the right time to go that direction yet. So so I would say innovation is always hard, because you definitely want to making those kind of things into the real product.
Can you talk to maybe a little bit about how important the environment is for creating innovation, and why that can make a really big difference?
That is a hard question, But on the other hand, it's because you're talking about the environment, right? And I would say is I always enjoy one group with very various background, and then because as we talked before, right? People are looking at things from different angle, and the conclusion will be different, or direction will be different. And when you're working with a group of people that have a different background, it's really fun because people's questions and the question from them, or the ideas from them, from totally different angles, and then by combining of their minds, or we priority or screen some of the ideas together, and then great work or patterns can be generated. And I can give you one example, which is my personal example. This is in my early years when I was in TE connectivity, and that time is I working very closely with one scientist, and he's a great guy, and both of us are passionate about how we can change design here, or change things here. And then that time, he's working in a touch screen. TE that time we sell the touch screen, which is major for the kiosk. So for example, if you go to the airport, and when you choose the different seats, or or different tickets, and some of those products are coming from the previous the Elo touch system there. And then, there's one thing we find very interesting, because that time we're looking at two things. One is multi-touch, because how we can get in one touch screen with multi-touch. And the other thing is, the screen of those kind of touch screen is too bulky. That's because in our technology, and then we put all the transducers and the receivers on the front of the touch screen. And then, in that case, you do need the bezel around to hide all the transistors and transmitters and the receivers behind. So we're talking about that, if for the end users, they like the screen to be clean, if we can have something we call the bezel-less, and then nothing on the front of the surface, and then that would be great. And the thing is, for the transmitter, we do is the acoustic touch system. So they need some kind of wave to go in the surface of the screen, and then we looked at the wave. The wavelength is very fine. It's less than 0.5. I think it's quite a years ago, so I couldn't remember. I think less than 0.5 millimeters, and then we saw that we might be able to hide in the things on the back, because by making the edge, which is round, although from human's eyes it's a round edge. But from the wave, the wave you're looking at, it's no difference. It's just, climbing from the behind to the top. So by doing this way, we can hide in all the transmitters and also the receivers on the backside. That idea is great. And then, we had a problem is, okay, so when we have everything on the backside, idea worked, we can test it in the lab, and then the wave can move in towards on the front. The question is how we assemble into a device, because for a device, you not only need a touch screen on the glass on the surface, you also need the electrical device or the analyzer or whatever on the backside. And we said, oh gosh, we don't know how to solve it. And we scratch our heads and you say, hey, how we can solve that problem? And his background and my background are more on the science, so we thought that this is too difficult. And when we struggling, and then one day we joined one of their meetings, and then we brought this up, and we said, we had a great idea, and however, we think that's the roadblock there is we couldn't assemble this device. And another engineer sitting in the same room, and he looked at us and to say, are you serious? That's the easy part. And we said, really? And he said, yeah, that's the real easy part. So we said, okay, great. So we pass you this kind of design, and can you assemble everything together? They did it, and this became, quite a major, product for that department. And on the other hand is we also combined the multi-touch with those kind of designs. So it opened a lot of new sales for that group. So But when you're talking about the environment, and I think it's diversity, and people have various background, and open mind. People are willing to asking questions and then provide feedback, and very interactive group. I think those are very good for form this kind of environment to generating innovation. And of course, another thing is as you mentioned before, right? And we need a problem statement. If we have a problem statement and with this kind of diverse background of group of people, and then another problem can be solved. And always not limit us. I said don't just say, okay, we couldn't solve the problem. Always think about it. This is an interesting problem, and can we approach this way or approach that way? And we are not shy to kill ideas, but on the other hand, it's always bring up the ideas and to say what is possible.
Absolutely, and that diversity of perspective, I think, is so important. And I think that's why it's a big emphasis within our company and with companies across the board right now, because it can lead to such game-changing ideas when you're able to just ask someone else a question. Maybe it helps solve a roadblock that you had to run into, or just opens your eyes to something you hadn't thought about. As someone who's clearly such a key innovator for the company, what would you say that the Clarivate Award means to you personally?
Oh, I'm quite proud of that. I think TE has been receiving this kind of award, I think, for the past 10 or 11 years. And it's a great recognition for the whole TE engineers, because each of us is part of that. And on the other hand I think we should encourage all the engineers in the team or in the company, and to say, think harder and to see, what kind of hard problem we can solve, and bring up new ideas. And I always say there's no stupid questions, right? Always bring up the questions and then engage into the discussion. And then, you never know is when one people's idea made another people's idea, and there's sparks in between, and then we can generate new ideas. And more importantly, we might generating some ideas that can turn into real product application there.
Yeah, I've definitely been a part of some sessions that have been fun. I like seeing how different people approach the innovation process. I've been a part of teams where everyone kind of writes ideas on Post-it notes, and the goal is to kind of think outside the box and throw the crazy ideas out there. And even if you might not know how to execute it, like you said, if you're just by saying something, sometimes it triggers something in someone else's brain, and next thing you know, you have something you can work with. One of the things that I like to ask people who come onto the podcast, I like to ask, when you look in the mirror and you reflect on everything that you've accomplished so far in your career and everything that you've done, what would you say your X factor is that has helped make you so successful as an engineer and as a scientist? What has helped you really stand out and really excel?
I'm not sure whether I'm successful or not. I think, there's a still, continuous journey for me to grow. But there's a couple of things that I value a lot. One thing is, as mentioned, I'm always curious about a lot of thing. I think this kind of curiosity making my daily life very fresh. So I would encourage people always, being curious about what can be done differently. And, if you always ask and say, hey, what can I do differently? And then, that might give you some kind of a different thought you never had before. And another thing is always being open-minded. And a lot of time we say, hey, we cannot do this, we cannot do that. And on the other hand is, there are a lot of things you can do. So think about is, where you can approach and then to get things done. So this is, and also is, in this world, you're not alone. There are so many different experts, and then there are so many knowledges around. Leverage them reach out and to talking to, this person or that scientist or that engineer, and to asking, say, what does this matter? Teach me, educate me about, what this technology is. And those kind of things will make you, much powerful, because, you're not like need to getting another degree or, reading tons of the books to get the knowledge. And those people can give you some conclusion in half an hour and give you the most practical knowledge, in the short term. So I think that is always a good thing, is being open-minded. And another thing is always try it. Take the challenge, take the opportunity. Another time is you always doubt about myself. At least sometimes I doubt about myself, is whether I can do it or not. And sometimes you will find is, if you spend, again, I usually joking with my team, if you spend 30 minutes or 1 hour to think about whether should I do it or not, then do it. Because, because the thing is, for the time you spend to think about it and to get you stressed about whether you do it or not, and then try it and to see whether you can do it or not. So, so put your energy into those kind of things, is try it, take the challenge. You won't be succeed in everything. But however, the more you try it, the more challenge you are willing to take. And then, the more things you will learn fast. And also you will find you can give people good, insights or share the knowledge as well. So for example, I'm still involved in another brainstorming session. And those kind of things make me happy, right? And another time is, when we're talking about those kind of things, we always say is what we can do, and we will do it. So I would say is we can do it, and take the challenge. This kind of attitude definitely help. And the other one I will definitely say teamwork. Teamwork is very, very important, because I said is nowadays one person can solve all the problems. It's really challenging, and the world has become more complex with one product or one design. You need to consider from the product design, material selections, and to the end product manufacturing process, and including the delivery. This is a whole chain, and then every people has their own expertise in certain area, and leverage those knowledge and working as a team together, and that will be very helpful. I did see a lot of success story is coming from those kind of open teamwork.
The open dialogue and your message about knowledge sharing. I've definitely found that people are more willing to share their knowledge and to educate others than I had initially expected. So it's been a very pleasant surprise, because everyone is kind of willing to just teach people and to share what they've learned, to share the conclusions they've gone to, because usually they're proud of the work they've put in to get there, and they're happy to share with others. So I think that's an important message and a powerful message, especially the part 2 about kind of just giving it a shot, spend the 30 minutes or the hour that you spend contemplating doing it, to just try your best. I definitely feel like sometimes the hardest part of any project is just getting started. I don't know, sometimes the blank screen, right? It's intimidating. It's really open-ended. And when you can just start, once you get something down, it just gets a little bit easier. The ideas start flowing, and at least you have somewhere and like something to work with. So I think that's really important to consider.
Absolutely. And another thing is, I want to add it, don't be afraid about the failure. The thing is when you try it, and be honest, right? The thing is, if the work doesn't work, kill it. And it's nothing wrong with that, but you have a clear conclusion to say, okay, this is not the technology path we will go. But at least, there's, you don't need to try this road for, endless for 2 years or more. Okay, that's not the direction, so we need to find other direction. So sometimes, know where not go is also very knowledgeable for that.
Yeah, knowing when to walk away or to pivot is also very important.
Absolutely.
Thank you, Ting, for joining us today. Please come back next time by subscribing to the show on YouTube, Spotify, or Apple Podcasts. Until next time, think big, move fast, and make every connection count.